Okay, so last time we looked at defining functions, and we defined functions that were conditional, like number of roots. And you saw then basically something that looks like an if statement. And if I were you, I think my next question would be, okay, I saw the ifs. Where are the whiles? Where are the for loops? There are no while loops. There are no for loops. There are no loops. Okay. Instead, what we do is we use recursion. So let me show you what that looks like. So I'll just erase everything. And let's write a nice, simple, recursive function. And the function that I want to write is this. I want to add up all the integers between 1 and n. Okay? So if n is equal to 3, I want to return 1 plus 2 plus 3. If n is equal to 5, is 1 plus 2 plus 3 plus 4 plus 5. Now, how am I going to do that? Before I actually write the ACL2, I want you to think a little bit about the equations that must be true to make this hold. So let's take a look at that. Okay, so I said I wanted to look at the equations that must be true of a function that adds up all the integers from 1 to n. So here's what I mean by that. Let's call the function sum up to n. Okay, and let's suppose that n is equal to 0. Okay. Now you can use whatever notation you like. You can use this notation, or you can use the more traditional, notation that puts the arguments only, parentheses only around the arguments. But I'm going to do it like this because that's what we've seen so far. And the equation that I want to say about this is that this has to be 0, right? I mean, that's what we mean by the sum of the functions up to n. Sum of all the integers up to 0, that's 0. So now let's look at the sum of the integers up to n, and this time let's just say it's actually n, right? So if I add up all the integers from 1 to n, what do I have? Well, what I really have is 1 plus 2 plus 3 plus ... up to plus n minus 1 up to plus n. Okay, now this is the way that the recursion is going to work. What we're going to say is we're going to look at this part and we're going to go, I recognize that. That is simply the sum up to n of n minus 1. Okay? And then we're going to add n, right? So actually we want this to be equal to sum up to n of n minus 1. Okay? We'll get that, and then we have to add n to that. Okay? So these two equations kind of capture what we mean by sum up to n. Okay? And I think you can see that in fact those equations are true, right? However our function is defined, that needs to be the case, okay? So my next step is going to be to take kind of these equations and actually turn them into code. Okay, so I've rewritten our equations right here so we can follow them, right? And our goal is to turn those two equations into some kind of code, right? So what you need to do to be able to do that is to have kind of an if statement or many if statements. And what the if statements will do is differentiate each one of those cases. Okay, and then it's just a matter of saying, oh, this is case 1, which corresponds to the first equation. I know what the answer is. It's 0. Oh, this is case 2. It corresponds to the second equation. I know what the answer is. It must be plus of, and so on. So let's write that. Define sum up to n of n. So how do I tell which case I'm in? I think you can see that really it's a matter of whether we're talking about 0 or a positive integer, right? And we know how to check to see whether something is a positive integer. So let's try this. If pos p of n, if pos p of n is true, then we're in the second case, right? So we can actually just code that directly. That's just sum up to n of n minus 1. And we're going to add n. Okay, that's it, right? If we're in the else case, oh, in that case we must be in equation 1. We know the answer is actually just 0. Okay, so that should be what sum up to n is. Okay, let's go ahead and accept that. Look at that, it came over here, right? So I can actually test it to make sure it works. So like sum up to n of 0. Yeah, that's 0. That's good. How about sum up to n of 4? That's 10, which is correct. 1 plus 2 plus 3 plus 4 is 10. So good. So I think we have a working function that adds up to n. So we saw how to define sum up to n using these two equations. But I actually want to try to write it in a different way that may be more familiar to you. So let's try this. What I'm going to do is I'm going to write sum up to n using kind of more standard mathematical notation, okay? So sum up to n of n is equal to, and now we have cases, okay? So it is equal to 0 if n equals 0, okay? And it is equal to sum up to n of n minus 1 add n to that if n is greater than 0, or I could also, sometimes this is just written as otherwise. Okay, so this is just another way of writing this notation, and you may, or rather writing a function definition, right? And you may have seen this before in mathematics. For example, you define the absolute value of x, which is a function, as x if x is greater than or equal to 0, minus x otherwise. Okay, that's kind of a classic definition of function by parts, right? So, these are the two parts, and whenever we have parts, what we'll do is just take if statements, right? And the if statement tells us what part of the definition am I in. The first part, oh, then return x. The second part, oh, return minus x. That's how all of these work.